Hey, so welcome back to the science lab. A little different than the science lab we used to use, but very exciting nonetheless. We got Luigi here with us today, right? Very exciting. So we're going to talk a little bit about air pressure, a little bit with how temperature and density relate to air pressure. Is this something you guys know a little bit about?
A little bit, yeah.
Yeah.
A little bit.
Cool.
I watch the weather every morning, and that's about it.
Good call.
Yeah.
Nice. Well, temperature, density, and pressure are super related to that. So we're going to start with sort of a simple experiment that just shows that air pressure does have a lot of power. We don't think about it as having power because, you know, the air just seems so light and flowy and it doesn't do anything.
There.
But it's there and it's pushing on all kinds of stuff. It's pushing on us right now, although we're used to it, so we don't feel it. So one way we can see this is we can actually have air hold water inside of an upside down cup. Okay? So Luigi, I'm going to have you do this one.
All
So
right, let's
pour water into there until it's about a third full into that glass.
About a third.
About a third. It doesn't have to be perfect.
You didn't tell
by
me there
any
was
means.
math involved.
Oh God, what's a third?
I'm not prepared for this.
Fractions.
A little more.
A little more, sure. The air can
There we
handle
go.
it. Cool.
All right.
All right. So now I'm gonna have you take this piece of cardboard, and you can use really any kind of stiff paper. An index card works really well as long as it's something that can cover the lid completely, or the top of the.
To cover all of it.
Yes.
Gotcha.
So go ahead and cover it up with that guy. Okay. Now hold it on tight, and what I'll have you do is bring that metal container over to you, and I'm gonna have you flip it upside down, Luigi, but flip it over that guy just in case something happens.
Okay.
Okay. Keep it tight on there.
Precautions must be taken.
Flip it. Okay. Now lift it away. And
Oh.
voila. Right?
Witchcraft.
Okay, so
There is no tape on this.
there's
There's
no tape at all,
adhesive.
right?
I mean, I'm pretty sure you guys can see the close-up right there. If you guys want to inspect it a little bit, you can tell there's nothing there.
and let's just talk briefly about why this is happening. Now, also, what is going to happen is the water is going to be mixing with that cardboard and soaking it, and so it is possible that it's just going to release on you.
Yeah, I
Luigi.
can
Right.
see it soaking in,
If-
so I'm gonna go
Well,
back.
and-
So go ahead,
Yeah.
flip it back over, and
And
let's.
the cardboard's not airtight.
The cardboard's not airtight.
Completely,
And
yeah.
if there is any kind of an air exchange, that's when we're going to run into a bit of an issue. So let's just talk about why that happened. So when you flip the cup, Luigi, what you did was the water poured down from the bottom of the cup, right? And it created a small vacuum space between the water and the bottom of the cup, which is now facing the ceiling, right? The vacuum space contains less air than the air around us, and therefore lower air pressure.
And so it's
Does that make
sucking
sense?
in it. Yeah.
So that even the force of the water itself, which is weighing down on that cardboard, is not enough to contend with the about 15 pounds of pressure that the air pressure is putting on the card, keeping it held up.
I've heard of a similar one, which is if you put like a newspaper flat and keep it flat real down, and you were to like put a stick in it, and you were to take a hammer and hit the stick, the hammer would break the stick because there's enough air pressure on the newspaper as a whole to hold the stick down.
That is a really cool one that I have not
that
heard
one.
about. I'm going
Yeah.
to have to look into that.
Again, like over that distributed area, all the pressure is going down.
Yeah, and you know, so one thing that you can do if you get it right is you can pull the card away and have the water stay in, but there's a lot of issues with that. If you have any kind of gas exchange through the air, it causes it to fall. And I tried it this afternoon a number of times and could not get
A
it.
lot
I
of
know what I'm doing
variables.
tonight.
Yeah, there you go. Playing at the same.
Cancel all plans.
So that is an experiment that you can totally try at home. You don't really need parental supervision for this unless your parents are upset with you getting water everywhere. So you should maybe check with them
They may be.
on that along those lines. But the next two experiments we're going to look at do involve either open flame or heat. So definitely adult supervision for the next two.
Ask your parents.
Okay, so we'll talk this one through before we try it, okay? And I'm gonna have both of you guys light a match in this one, so you each have a matchbook. Okay. So air pressure is really related to air temperature, and hold off on that light, and I'll give you guys the go-ahead, okay?
Getting a little excited.
Right,
Sorry.
it is very exciting. Matches. So, okay, when you heat air, air expands, and when you cool it, it contracts, right? Okay, so what we're gonna do is we're gonna throw 2 lit matches into this flask that I've got here. What's gonna happen to the air inside it?
It's going to
Expand.
expand.
That is exactly right. So the quantity of air, and we can imagine right now the air pressure all around us is equal to the pressure inside that glass. The temperature is the same, everything's the same, and there's a flow, right? As you guys heat up that air, what's gonna happen to it? In terms of will it expand or will it contract?
It's going to expand, so
It's gonna
I
leave.
would figure it would leave, yeah.
Exactly,
leave
so
the-
a chunk of that air is gonna leave. Now, what we'll do is I will be waiting off to the side with this hard-boiled egg, okay?
Ooh.
So this hard-boiled egg fits pretty perfectly in the top of this flask, but it will sit, as we can see right here, on top, right? So the idea goes, if we can expand the gas inside here, have some of it pushed out, and then I can seal it really quickly, we should have lower air pressure inside of the flask than we do outside, which should cause the egg to be pushed into the flask. Are you guys
Kind
ready?
of like the paper was sucked to the cup.
Yeah, like very much the opposite thing, exactly. Or very much the same thing, let's say.
Just in different, yeah.
Right, different directions.
Yeah.
Right. So, okay, one thing I need you guys to do, once you light the match, give it just a second to catch the stick, okay, and then I'll do a 3, 2, 1. Have you guys throw it in there, and I'll cover it.
All right.
Ready,
Gotcha,
steady?
gotcha.
Okay, go ahead. All right, 3, 2, 1, go ahead.
Oh, there it goes. There it goes.
Come on, egg, you can do it.
He doesn't want to go in. He knows what's down there.
Well, so air pressure should continue to work on it. It's probably caught a little bit there, but that's totally fine, right? Kind of a cool experiment.
Right. Either
So-
way, it wouldn't have done that on its own.
So
Yeah.
we'll let Mr. Egg hang out here, and we'll see if it gets sucked all the way in, if the air pressure pushes it all the way. But really cool, simple experiment you can do to show how temperature affects air pressure, and then how that air pressure interacts in the real world. Right?
Really interesting.
Okay. Well, the last one's my favorite. It's pretty cool to suck an egg into a flask. But okay. So what do I have here?
Ice water.
Pitcher of ice water.
Pitcher of ice water. Okay, and then over here to the side, and
so
I'm
smart.
so happy.
We are.
The water inside is boiling, which is fantastic. I have 2 soda cans, which have a little bit of water, just about a tablespoon of water boiling inside of them. Okay, so I've got hot water here, cold water here, but also since these are mostly empty, there's a lot of hot water vapor inside of these guys, right?
Yeah.
Okay.
Yeah.
So I'm gonna have you guys make a prediction. I'm gonna have each of you do this because it's cool enough that it's worth doing twice. Okay. So Becca, I'll have you go first since you're the closest. All right?
Okay.
And let me walk you through it before you actually do it. All right.
Okay.
So you're going to carefully grab and make sure you have a good grip on that soda can.
Okay.
Okay. And then you're gonna quickly flip it, and there is a little bit of water in there, a little bit of hot water. So just go ahead and flip that right into there. And I want you to put the tip of the can right into the water.
So just the tip of the can.
And you can kind of stick it in there. But my question is, what's going to happen?
Okay, so air pressure outside is more, more, because the air is escaping from there. So this is more. And so more, less, it'll have some force on it.
So it's actually less the air pressure. Well, it does have to do with the air pressure outside, definitely. But what's going to happen? So if there's steam inside, right, which used to be liquid water,
Right.
now it's steam molecules, water vapor molecules bouncing around. What's going to
high
happen when
pressure.
what's going to happen when those things get cold?
They're going to contract.
They're going to contract.
Yeah.
They'll actually turn back to water.
Right.
As they contract, they're going to take up more space or less space.
Less space.
And that's what's going to create the lower pressure on the inside, higher pressure on the outside. What should happen to the can?
It's going to collapse.
Hopefully it'll collapse if all goes well. Okay, you ready, Becca?
Yeah, I'm ready.
Okay, cool. Carefully now. So make sure you got a good grip there. Yeah?
Got it.
Okay, flip it in.
Woo! That's so cool.
Look at that, not too bad, right?
And
Isn't
here
that
I've been
incredible?
crushing cans with my hands like
Yeah,
an
I was going to say,
idiot,
we just
you
need
know?
to
Right.
Yeah.
All we needed to do
What
is
are we
heat it up
doing?
and stick it
Put
in
it
a
in
thing
some
of ice
water,
water,
yeah.
right? Cool, all right. Well, Luigi, just because this is cool, I did want to give you a chance to do it too.
Let's do this.
Okay? So once again, Luigi's grabbing the boiling jar. Be careful with it. Perfect. He's flipping it.
Oh,
Boom!
That's so cool.
that
Also get
kind of
that nice
catches
little-
you off guard.
It does.
Yeah.
You think it would happen a little bit more instantly or
Yeah.
not, or I don't know.
Yeah, so I tried this once with a group of students earlier today, and I didn't quite have the temperatures right, and it didn't happen. So when I did it the second time, they were like, "Oh, nothing's going to happen," and then all of them kind of jumped when
It scared them.
so
That's
that was
funny.
really exciting for me.
Yeah.
But kind of amazing what air pressure can do, right?
Yeah.
We don't think of it as having as much power as it
As
does.
much power, as much force, or yeah.
And it's also worth noting that there's a lot. If you can hear that, there's a lot more water in it now.
Right, which some of which is going to be the condensed vapor, but some of it is also going to be this.
Exactly. Yeah. Kind of like. Yeah.
Right.
It's cool.
Cool. Well, yeah, so a couple experiments with air pressure there. Hopefully you guys enjoyed that. Hopefully you guys did as well.
Oh yeah.
Okay, cool. Well, thank you so much for watching. We'll see you back at the homework hotline desk in a few minutes.
Subscribe.
Subscribe.
Come on, push the button.
You know you want to.
Do it.